Quicksort is a efficient sorting algorithm that works by selecting a pivot element from an array and rearranging the other elements so that those smaller than the pivot element come before it and those larger come after. This process is repeated for the subarrays on either side of the pivot until the entire array is sorted. It's known for being fast and requiring less memory since it sorts the array in place, but in the worst case, it can be slower if the pivot choice is poor. The- It is commonly used for large database due to average time complexity. Key concepts: divide and conquer pivot element. Pros cons: divide and conquer. The algorithm splits the array into smaller subarrays, sorted those subarrays, and then combines the result. Pivot element. Quicksort uses a pivot element to partition the array two smaller subarrays. One all elements are smaller than the pivot and one element with the greater. The pivot is placed on the correct position and the process is repeated for the two subarrays. Choose a pivot element from the array. This can be done in various ways such as selecting the first element, last element and random element. Partition the array into two subarrays, one with element smaller than the pivot and one is with the element greater than the pivot. Recursively, they apply the quicksort to these two subarrays. This is done until the subarrays of size of 1, which means they are already sorted. The sorted subarrays then combine, but since each subarray is already sorted, no further merging is required. Very efficient for large data sets. In place sorting, which means it does not require additional memory for any another array. Often faster. The partition of other algorithms like merge sort deposit having the same average time complexity. Cons: not stable means equal elements might not maintain their relative order. Pseudocode functions quicksort array low high. If low greater than high less than high, pivot index equal to partition arrow comma low comma high quicksort array comma low comma high pivot index minus 1 quicksort array pivot index plus 1 high function partition array comma low comma high pivot equal to array of high I equal to low minus 1 for j equal to low to high minus 1. If array of j less than or equal to pivot I equal to I plus 1, swap array of I and array of j. Swap array of I plus 1 and array of I, return I plus 1. This is the example for the quicksort. Expression of array image. The sorted of quicksort were given the selecting the 14 as the pivot element. The array is partitioned into two parts less than 14, 12, 13 and 11. Elements greater than 14, 16 and 15. This is ensures all elements to left to right and smaller which those are right are larger. Next we apply recursive the left partition choosing the 12 as the pivot element. We further divide the subarray into elements less than 12, 11 and elements greater than the 12, 13. Since both are already sorted individually, merge them result into the sorted sequence 11, 12, 13 as. Moving to right partition, we select 16 as the pivot and divide into elements less than 16 and no elements greater than 16. Since both the elements are already in the order, this results in the sorted sequence 15 and 16. Finally, we combine the sorted left partition, the pivot 14 and the sorted right partition. This gives fully sorted array 11, 12, 13, 14, 15, 16. Completing the quicksort process.